All right, so welcome to Night Hacking at the Jfokus conference. My name's Stephen Chin. I run the Oracle developer community, and I'm joined by Sam Aaron, who does cool synthesizer stuff with code.
Oh, yeah.
So that's pretty awesome. And you were doing this at the keynote earlier today. I've seen you do this at other noteworthy keynotes at developer events, which is super awesome. But
Yeah.
it'd be interesting to find out a little bit more about the technology behind what you do.
Of course. Yeah.
All right, so let me swap to your screen.
Cool.
So folks can see what you're up to.
Yeah. So this is the this environment I'm using. It's entirely free, open source, and it runs on Windows, runs on Mac, runs on Raspberry Pi computers or Linux, and on all operating systems it looks the same. I've got some fancy graphics here, but essentially you type in text, you press run, get an error. If it was correct, you'd get some music, right? And the goal really was to teach kids how to code. So the simplest program you can write is just a simple one-liner, and you press the special magic run button, and you get a beep, right?
Nice.
And then if you want to play 2 notes, it plays a chord. Now, this might be the point where, if you've never seen Sonic Pi before, the system, it might surprise you because you might expect first note, then the second note. But immediately we're dealing with time. And most programming languages don't deal with time, really. They talk about concurrency at the same time, but they don't talk about on time. That's a rare thing to talk about, really. You talk about do this, then that, and make sure this happened before this started. So order of execution is really important, but not at the same time. But here, actually, if you look at the logs on the right, you can actually see it at time 0 here. Both these notes are played.
Yeah, okay.
So we've got chords. So if we want a melody, we need one more command, and that's sleep. And now we have a melody. Super exciting. I'm sure you can imagine the possibilities at this point. But this is all of Western music, pretty much. Like, you can play any melody, any riff, any bass line, Daft Punk, Mozart, with just these 2 commands. And they're simple enough for kids to do.
I mean, as long as all the notes are exactly the same length, you're set.
Yeah. So if you want longer notes, right? So you just change, like, so in synthesizer terminology, I need to put a comma in here. So we change the release time to, well, 1 is the default. Or if I change it to 0.1. Or I can change the attack time.
Oh.
So fade in. This is like if you look at the documentation, there's a section on the duration of envelopes. And you can see like the default envelope goes from quiet to loud and then fades out. But you have access like the full ADSR envelope if you want can change the length and modify, modulate the amplitude. Yeah.
No, that's pretty cool. So you have any examples of some of your compositions which you've
I mean, so
this?
you can do 2 kinds of things with the system. So already there, without play and sleep, you can compose a melody. But you can also what we call live code. So there's a bunch of other programming environments for live coding. It's not something I've invented, but it's something that's I'm making much more accessible. And the premise around that is this idea of a live loop. You give it a name like foo, trigger a sample like ambi choir, sleep for some amount of time. You can hear that. Maybe make it a bit louder. Change the rate. So you can. What I'm showing here is that the compositions don't have to be something you compose and you press play. It's something you can actually start to tweak.
So you can actually tweak it.
Yeah.
Make the music while you're.
But yeah, we have a bunch of built-in examples here that start from Apprentice to Algomancer in terms of their complexity. And so we can start off with some sort of simple like ambient sounds where you just cut and paste these chaps into here. And here's. If we can, here we are.
Yeah, so this has 3 live loops.
Yeah. So and each live loop is a thread, so this is concurrent.
Okay, nice.
Right, or you can even have multiple buffers running at the same time. So if I load another example, let's load like the oceans. And they're going at the same time, right? So you can combine these things. Or let's load this one. So this is much more. I was listening to some Daft Punk and thinking, how do I make something that's simple that I explain to a child, but also that sounds sort of interesting, right? And of course, you can live code this. If I can take the drums down. Right, so commenting is actually mixing. And then maybe change the effects, crush. Make it a bit louder. Add some more synthesizers. This is going to sound crazy.
Thinking about what you want to get out of the music, but then live coding and making the changes in the right.
I think the secret is the same as any musical instrument, just a ton of practice.
Yeah.
Basically, so you spend a lot of time making horrible sounds, and that's totally normal, right? So when you first play a violin, it's going to sound horrendous, or the guitar, but you keep practicing, right? But the cool thing about this is, if you happen to stumble across something which sounds nice, the code will always reproduce the same sound.
You have that code, you can save it, you can replay it, you can mix it in with other sounds.
Precisely, and but those sound like very easy things to say, but from a programming perspective, what we're really talking about is determinism. And this is a concurrent system, so I put an awful amount of effort into making sure that everything's fully deterministic. So the same code will always produce the same sounds.
Nice.
And then I make sure that the two independent threads, when you play them together, they also still will do what they did originally. So like they won't interfere with each other, which means that, for example, things like randomization. Like typically randomization is you're pulling from a global rand, right? And so if you mix two threads together that are both calling from the same rand thing, then they're going to have different behaviors, whether it's one or the other or together. So those kinds of things I've avoided and put special care into making sure it doesn't happen.
I see. So even for randomization, like if you are relying on random, it will play exactly the same random sampling.
Let's have a look at this. So if I play a random note, that's ranged rand between 70 and 100, release time short, sleep for a small amount of time, if I can type in correctly. Well, actually, rather than do that, let's just do it 8 times.
So always
I'm seeding the same thing.
Oh, interesting.
But
can
actually,
you adjust the seed values?
Oh yeah. So you just say use random seed. Where are we? There, some value.
And then across different threads, it'll actually pick the rands in exactly the same order.
Yeah. So like the random seeds are thread local.
Yeah.
And the randomization system actually does not use the standard weird mathematics that's sort of trying to find well entropized, or even word, high entropy stuff. This is actually a WAV file of white noise that I have an index into. So each thread has its own pointer into that thing. And so here I'm just skipping to whatever 300,000 in that list, and it's a ring. So when you get to the end of it, it just repeats around.
And then if you hear like a nice sequence, even if it's random, you can exactly reproduce it with the same code.
Precisely. And this is actually really beautiful because what I'll do is I'll listen back to some of my practice sessions. If I like a riff, I'm able to just find that same seed and the same chords and reproduce it again. So actually, composition is a case of just choosing the right seed. Keep changing it until you find something nice. So that re-res thing I was showing you earlier, actually, I just happened to choose the first, and that happened to be nice. But if I change the seed to something else, let's change it to like 3,000. And that may or may not be what you want. But I happen to know that 3,000 and 4 of these, and then this as 4 is. And I know what it's going to sound like. So I'll switch to this. So remembering the random seeds and octaves actually will help you reproduce music that you've produced at home by chance. So you're not having to, like Bach or something, imagine the composition in your head like some sort of gifted musician. You can just really stumble across stuff you like. And then when you have done, you can just email it to your friends and they can reproduce it. And then you can have conversations through text over emails.
So are you ever surprised by like compositions or things the kids in your workshops come up with, or other folks who you teach the system?
All the time. It's really impressive. I mean, one of the most memorable things was went into a school and told the teacher, we're going to do some live programming. We're going to change the code as it's running. And the teacher's like, no, not with these kids, you know. And at the end of the session, they all did their own performance. And then 2 girls stood up, and they were very nice, sensible-looking girls with straight hair and all very smiles. And then this most ridiculously dirty industrial sound just blared out the speakers. So just don't judge a book by its cover. It was fabulous. Yeah.
Nice. Is there any sort of like place which people share compositions or community of folks using your software or any?
So there's, yeah, I mean, I have almost 1 million users that I know about,
Yeah.
and they're ranging from people who are working with children in schools or in workshops,
Yep.
from low years into sort of 6 to 10, to middle schools, even at tertiary education. So universities are using Sonic Pi to teach sound design and sound production. There are musicians using it to perform around the world.
Cool.
There's a chap who's about to release a new album, which is 95% made with Sonic Pi. Which is lovely to see. There was a guy who made an opera in Sonic Pi.
Wow.
A couple of days ago, I got 2 tracks sent to me. One was a rock track, like heavy metal, so really well-timed kick drums, so crazy, crazy drums played really accurately. And then also a lady who produced a fabulous Indian track with the tabla drums, and all of it was made with Sonic Pi except for the voice and some guitar.
Cool.
Yeah, because you can also, I mean, what I've shown so far is producing the sound from the language. But also the language allows you, like if I write live audio and give it a name, and if I had a sound card with a guitar plugged in, you'd hear a clean guitar, right? And if I then do some like with effects reverb, if I spell it correctly, and I run this, now I have a guitar effects with reverb. And then if I nested like this, now I've got distortion and reverb. So each of these lines of code is about $100 of effects pedals, right? And I've got them for free. And of course, like any guitar effects pedal, you have lots of knobs to modify. Each of these things has its own knob. So this one has amp, room, mix, damp, premix, preamp. And so you can control these parameters, but just by adding some options on the end. So if I just say the room size is 1, it's going to be a big, massive room, or 0.1, it's going to be a very small room. So the same way with pedals you can control, you can with this, but you just add a bit more code.
Cool. And when you do gigs with this software, like what's your usual hardware setup? What do you?
Well, first of all, I go into nightclub mode. That's the first thing. And then I have like a bunch of external synthesizers I play with. And depends where. If I'm at home, I might have large ones which fit at home.
Yeah.
But if I'm on tour, then I'll have the small ones. And I've got this little Moog Mini Tour and a strike fet, Waldorf strike fet thing, which are strings, and they're controlled by MIDI. So where I did before, like 8 dot times, do play whatever arranged round number, that's between 70 and 100, right? And I slept for some time, like 0.5 and end, right? That's playing the. Right, but if I change that one command to MIDI, it's going to send to all my MIDI synthesizers.
Oh.
So I get exactly the same structure and the same semantics. Instead of triggering the internal synthesizer, I control external synthesizer.
Got it. So then you can do a range of different external synthesizers
Precisely.
and do even more complicated.
And then you combine that with the live audio. If you plug the external synthesizer back into your sound card,
Yep.
and now I'm able to hear it inside of Sonic Pi, and then I can then add some reverb or whatever to my synthesizer. So I can control and manipulate the audio from code, which is huge fun.
Cool. Okay, so for folks who want to find out more about Sonic Pi, what's the best place to go?
Well, here's like some information here. Let's make this a bit lighter so you can see. So here's a website, sonicpi.net, sonic-pi.net. And Twitter, the account, is probably the best place to find what's going on.
At
That's
Sonic
at Sonic_Pi, P-I.
All right, cool. Thanks very much for the interview, Aaron. This was awesome. And,
Thank you. Oh, wait, one
thanks
more
very
thing.
much for our audience here.
And one more thing,
Yeah.
we have forums here, so in-thread.sonic-pi.net.
Nice.
Where it's not just programmers there's musicians and teachers. It's a great place to go and share ideas.
Cool. All right. Thank you very much.
Thank you.